So with the continuation, so now we have to see how the ANN is working. So we are having that biological neurons, dendrites is there, soma is there, axon is there, it's giving that conduction and making that next to communication. So now here we have to implement this artificial neuron as with the pattern of x0 up to that xn seems to be the inputs what that the dendrites is doing. So in the same way x0 to xn is doing, and we have to be add up that the weights. So this is the thing that is happened at that neuron. For that every input we are having that appropriate weights, so we have to be multiplying these weights with the inputs from W0 to that, so Wn. So and now we have pre-processing that element. So here we have to be go with that summation and that's activation. So what's happening in that summation? We have to be y0 equal to the multiplication of the w0 into x0. Same way y1 equal to adding up of that weight with that input, and then so yn equal to adding up of that weight with that xn inputs. So we have to be add up that everything that's it's giving that sum, and we have to be go with that activation function. So this is that artificial neuron is an imitation of that human neuron. So now so this is the simple structure of that ANN is. This diagram explains that how the ANN is working. So this is that single neuron, same way x1 multiplied with the W1, and that has to be transferred to the summation unit, and we have to be go with the transfer function, and finally the output is as a feeder to that other setup of that neurons. So this is the basic functionality that's happening in that artificial neural networks. So input multiplied and summation. So summation equal to x1 plus x2 plus x3 up to that xm, it's that y. So and we have to be go with that processing. Before that processing, we have to be add-ups of the weights for that appropriate each and every inputs. So x1 w1 plus x2 w2, x3 w3 plus xm wm, so that's equal to y. And finally we have to be produce that output. So I equal to 1, that's varying up to that m, and xi into wi equal to y. So this way that ANN is working, but in the transfer function we have to give that xi wi equal to vk. So yk equal to, that is the output, yk equal to f of vk. So the vk that has been substituted by that summation of I equal to 1 is varying from that m, so xi wi. So the output is a function of the input, so that is affected by the weights and the transfer functions. So every activation function after that summation, that is that vk, so that is f of vk, it's varying from that y of yk for the each and every combinations. So that has to be summed by summation factor and finally produce, that is that f of u. So this way we have to be considered that activation function that has to be in that output and transfer the functions into the next varieties of that neuron. So an artificial networks and ANN can able to compute that any computable function by that appropriate selection of the network topology and that weights values, and it has to be learned from that experience, specifically from trial and error mechanisms. So learning by trial and error, the continuous process of that trial and evaluate and adjust that. So processing that input to produce an output. In terms of that ANN, we have to say compute the output function for that given input, and that has to be evaluated by that output, and we have to be comparing what that actual output and what is that expected output. In case if we couldn't able to reach that expected output, we have to be adjust that weights of that input, so what we provided, that's from w0 to so wn. So now we have to be see how it has been working. So set that initial values of the weights randomly. Since we won't able to fix this is that weight for that each and every input, we have to assign that randomly, and truth table of that XOR that has to be given, and then this is that protocol we have to do. Read that input, either that example 0 and any other thing, and compute an output. What is the value of that output? So compare it to that expected output. So what will be the difference it's happening, and modify the weights accordingly. So loop until a condition is met. So for the conditions, certain numbers of the iterations. For the conditions, we have to be go with a certain error threshold. And we have to see what is that design issues. So initial weights may have that random values of -1 to +1 of the inputs, and the weights are to be combined to produce that output. So that is the transfer function, and we have to be look over into that error estimation and weighing that adjustments, and the number of the neurons we are working, and data representation, and size of the training set. So in transfer functions, there is the 3 steps: linear, threshold, and then non-linear. So the linear output is proportional to that total weighted input, and in the threshold, the output is set at one of 2 values, depending on whether the total weighted input is greater than or less than some threshold value. So in non-linear, the output varies continuously, but not linearly as the input is changes. In that error estimation, we have to be go with the root mean square error, that is RMSE, is a frequently used measure of the differences between values predicted by a model or an estimator and the values actually observed from the thing being modeled or estimated. So weights adjusting after that each iteration, weights should be adjusted to minimize the error, all possible weights, and by the back propagation. And what is that back propagation? So back propagation is an example of the supervised learning which is used at each layer to minimize the error between the layer's response and the actual data. So the error that's happening in the hidden layer, we have to be take out an average and evaluate the errors. The hidden layer networks are trained this way. So this is the parameters behind, that is the back propagation. So N is a neuron, NW is one of the N's inputs weights, and N out is N's output. So now N's output equal to NW, that means input weights plus lambda of that NW. So lambda of that NW equal to N out, that should be multiplied with that 1 minus N out and multiplied with that error factor. So now error factor equal to expected N of expected output minus N of actual output. So this way we have to be compute that back propagation. So this works only with that last layer. So we have to be compare with that actual output and then so expected output. So now we have to be continually see on that how this ANNS is working.